UGC NET Electronic Science January 2025 question paper solutions part 2, that is from question number 76 to question number 100. Question number 76, find the Z parameters of a lattice network. Given lattice network is a symmetrical lattice network where ZS is side impedance or diagonal arm impedance or side arm impedance. The value of side arm impedance is 8 ohm and the value of adjacent arm impedance is 4 ohms, and the formula for Z parameters is Z11 is equal to, this is a symmetrical lattice network, Z11 is ZA plus ZB by 2, that is sum of adjacent arm plus side arm by 2. Z11 is same as Z22 and Z12 is equal to Z21. Its value is side arm minus adjacent arm by 2. Using this formula, the value of Z11 is side arm plus adjacent arm by 2, 8 plus 4 by 2, 8 minus 4 by 2, that is Z12. Z21 is 8 minus 4 by 2 and Z22 is 8 plus 4 by 2. The value of Z matrix is 6, 2, 2, 6. Correct option is 3. Z11 is 6 ohms, Z22 is 6 ohms, Z12 2 ohm, Z21 is 2 ohms. Next question. Arrange the FFT of an given sequence x of n is 0, 1, 2, 3 in the ascending order of k in x of k. The problem can be solved by using DFT, discrete Fourier transform, and the formula for discrete Fourier transform, x of k is equal to sigma n is equal to 0 to n minus capital N minus 1 x of k e power minus j 2 pi nk by capital N, where capital N is period of the sequence, that is periodicity. X of 0 is sum of all values in the sequence x of n, that is 0 plus 1 plus 2 plus 3. Its value is 6. X of 0 value is 6 and x of 1 is sigma n is equal to 0 to 3 x of n minus j power n, because e power minus j pi by 2 whole power n, its value is minus j power n. Now the sequence for x of 1 is x of n, after calculation it results minus 2 plus 2j. Similarly, x of 2, for this x of 2, e power minus j pi whole power n, its value is minus 1 power n. X of 2 is minus 2. On calculation, x of 2 will give minus 2 values, and capital X of 3, that is e power minus 3 pi by 2 whole power n, its value is j power n. The value of x of 3 is minus 2 minus 2j. Now the sequence capital X of k is x of 0 is 6, x of 1 is minus 2 plus 2j, x of 2 is minus 2, x of 3 is minus 2 minus 2j. In the question, ascending order of k, that is x of 0, x of 1, x of 1, x of 3. 6 is x of 0, that is A, and then x of 1 is C, x of 2 is D, x of 3 is B. Ascending order of K. Suppose in the next question, for a metal semiconductor system, four different statements are given. Identify the correct statement. Statement A. Most covalent semiconductor surfaces have high peak density of surface states or surface defects near the neutral level, and the neutral level is about Eg by 3 from the valence band edge. The statement is correct. And statement B, the maximum energy necessary for electron to escape into vacuum from initial energy at Fermi level is called work function. It is not maximum energy, it is minimum energy necessary for an electron to escape into vacuum from the initial energy at the Fermi level is called work function. Statement 2 is wrong. Statement B is wrong. Statement C. For germanium and gallium arsenide, the dependence of optical dielectric constant on wavelength is similar to that of silicon. Statement C is correct. Statement D. For a metal semiconductor ohmic contact, specific contact resistance decreases as barrier height decreases. Statement D is wrong. The correct option is statement A and statement C are correct. Correct option is 3. So the work function is defined as minimum energy required to remove an electron from the surface of the material at 0 Kelvin. Specific contact resistance in statement D, specific contact resistance is given. So this specific contact resistance, it quantifies how much resistance exists at the interface between metal and a semiconductor. In a metal semiconductor ohmic contact, specific contact resistance tends to decreases. This specific contact resistance tends to decrease as barrier height decreases. 0 point energy or ground state energy is the lowest possible energy that quantum mechanical system may have, and Fermi energy is the maximum possible energy possessed by the electron of a material at absolute 0 Kelvin. Therefore, statement A and statement C are correct. Next question, arrange the following TTL series in ascending order of their corresponding speed power product. So the unit for speed power product is picojoules. So let us see different subfamilies in TTL. The TTL family has several subfamilies including standard TTL, low power TTL, high power TTL, low power Schottky transistor logic, Schottky transistor logic, advanced low power Schottky TTL, advanced Schottky TTL, and fast TTL. These are the different subfamilies that exist in transistor logic family. And the figure of merit is defined as the speed power product. It is simply the product of propagation delay and power consumption by the typical gate. And the values of different values of different values of speed power product are mentioned for different subfamilies in the question. 74LS low power Schottky TTL, it has 18 picojoules. The speed power product is 18 picojoules. And 74 standard TTL, it is 100 picojoules. For 74S, 57 picojoules. 74S is Schottky TTL. 74 ALS advanced low power Schottky. For advanced low power Schottky, speed power product is 12 picojoules. In the question, descending order of their speed power product. So highest is for 74, that is option B, and lowest is for option D. So followed by, so correct option is 2, B, C, A and D. Next question, following statements are true while determining the stability using Nyquist plot for the closed loop systems. This Nyquist stability criteria states that number of encirclements about the critical point minus 1 plus j0 should be equal to the poles of open loop transfer function which are in the right half of the S plane. Therefore, n is equal to p minus z, where p is number of open loop poles in right hand side of S plane, z is number of closed loop poles in right hand side of S plane, n is the number of encirclements about the point minus 1 plus j0 by g of s h of s plot the positive direction of encirclements being anti-clockwise. For stability, the condition for stability is z is 0, that is n is equal to p. The statements in the problem are the critical point for determining the stability is minus 1 plus j0. Statement A is correct. The critical point for determining the stability is minus 1 plus j1. It is wrong. The system is stable if and only if there is no zeros in the right hand side of the S plane. Statement C is correct. So statement D is wrong. Therefore correct answer is A and C. Option 1 is the correct answer. Next question. A dielectric material has relative permittivity of 18 and loss tangent is 10 power minus 3 at 100 megahertz. Find the conductivity of the medium. We know that loss tangent is tan delta is equal to Jc by Jd. Conduction current density to displacement current density. It can also be written as sigma by omega epsilon, where omega is 2 pi f angular frequency. Given frequency is 100 megahertz and relative permittivity is 18. We know that the value of epsilon is epsilon naught is 8.854 into 10 power minus 12. So substitute the given values in the formula. Loss tangent, that is tan delta 10 power minus 3, its value is 10 power minus 3, sigma by omega epsilon. We need to find the conductivity of the medium. Sigma omega is 2 pi f, frequency is 100 megahertz, 100 into 10 power 6, epsilon naught, epsilon r. So relative permittivity is 18. We know that 1 by 4 pi epsilon naught, its value is 9 into 10 power 9, that is 1 by epsilon naught value is 4 pi into 10 power 9. So 1 by epsilon naught value is 4 pi into 10 power 9. On solving, the value of conductivity is 10 power minus 4. The nearest option is 3. Some more points related to loss tangent. The loss tangent is a measure of how much a material dissipates electromagnetic energy, and it is also known as dissipation factor. Loss tangent is also known as dissipation factor or loss factor. Loss tangent is tan delta is equal to sigma by omega epsilon. Loss tangent represents the dissipation of electromagnetic energy in a dielectric material. Dissipation of electromagnetic energy in the dielectric material. So here option is 3 is the correct one. Next question. The mathematical form of Ampere circuital law is. So this Ampere circuital law differential form is del cross H is equal to Jc, and integral form is closed line integral h bar dot dl bar is equal to open surface integral Jc bar dot ds, that is current enclosed. So correct option is 3. Line integral of h bar dot dl bar is equal to current enclosed. Next question. One of the following can also act like a inverse transducer. So different options are given. So let us see the definition of transducer and inverse transducer. The transducer converts non-electrical quantity into electrical quantity, whereas inverse transducer converts electrical quantity into non-electrical quantity. Examples of transducer are photoconductive transducer, thermocouple, pressure gauge, strain gauge. Examples of inverse transducer are current carrying conductor placed in a magnetic field, piezoelectric transducer. So here piezoelectric crystal can act like a inverse transducer. Piezoelectric crystal can act like a inverse transducer. Rest three options: 1, 2, 3. Electrical resistance potentiometer, linear variable differential transformer (LVDT), and linear variable differential transducer, capacitive transducer. All these are transducers. All these are transducers. Whereas option 4 is an example for inverse transducer. Next question. Out of m transmitted messages, only one is having probability 1 and all others 0. The entropy is. So at probability p is equal to 0 or at probability p is equal to 1. At probability p is 0 and probability p is 1, the entropy is 0, whereas the entropy is maximum at when the probability is 0.5. Therefore correct option is 1, that is 0. At probability 1, the entropy is 0. Next question. LVDT, linear variable differential transformer or transducer, is used to measure linear displacement. This LVDT is used to measure linear displacement. It converts mechanical motion of an object into electrical signal, allowing the precise measurement of distance and direction. So this LVDT works on the principle of mutual induction. The working principle of LVDT is mutual induction. Correct option is B. LVDT is used to measure the displacement of an object. Next question. The capacity of Gaussian channel. So capacity of Gaussian channel, it is given by Shannon-Hartley theorem, also known as Shannon's information capacity theorem, defines a maximum rate at which information can be reliably transmitted over the noisy channel, with channel capacity C is equal to B log to 1 plus S by N, where S is signal power and N is the noise power. This source coding techniques is used to reduce the redundancy. Examples of source coding techniques are Hoffman coding, Shannon-Fano coding, and variable length coding used in digital communications. Next, this satellite communications generally operates at gigahertz in between 3 gigahertz to 30 gigahertz. And the satellite frequency bands are L band 1 to 2 gigahertz, C band 4 to 8 gigahertz, X band 8 to 12 gigahertz, Ku band 12 to 18 gigahertz, and K band 26 to 40 or 26 to 30 gigahertz. And this OFDM, orthogonal frequency division multiplexing. OFDM is a technology used in fourth generation long term evolution networks to split the carrier bandwidth into smaller subcarriers. Okay. Now, list 1 and list 2, we need to match the capacity of Gaussian channel, that is Shannon-Hartley theorem. Capacity of Gaussian channel is Shannon-Hartley theorem. Source coding, Hoffman coding. Hoffman coding is an example of source coding. Next, 4G, fourth generation cellular systems use orthogonal frequency division multiplexing. Satellite communication uses frequency in gigahertz, that is from 4 gigahertz to 30 gigahertz. So correct option is A3, B1, A3, B1, C4, D2. Correct option is 2. Next question. For a reflex klystron, which of the following statements are correct? So this reflex klystron is a single cavity low power microwave generator, and the efficiency is about 25 to 30%. So let us see the statements. It is a single cavity klystron. Statement 1 is correct. It is a high power generator. It is low power generator. The bunching parameters has negative sign. Statement C is correct. The maximum theoretical efficiency ranges from 20 to 30%. It is 20 to 30%. The effect of space charge forces and the electron motion is neglected for analysis. Statement E is correct. Therefore, correct statements are A, C, and E. Correct option is 1. Because the efficiency of reflex klystron is 20 to 30%, and it is a low power generator. Next question. A feedback network used in Colpitt's oscillator. So this Colpitt's oscillator is used to produce radio frequency oscillations, and the frequency of oscillations is given by frequency f is equal to 1 by 2 pi square root of L C equivalent, where C equivalent is C1 C2 by C1 plus C2. These two resistors are connected in these two capacitors are connected in series. In tank circuit, capacitors are connected in series. Now, in the question, the frequency of oscillation is given, that is 1 megahertz. Frequency of oscillation is 1 megahertz. 10 power 6 is equal to 1 by 2 pi square root of L equivalent, L into C equivalent. Whereas the value of inductance given, inductance L is equal to 20 millihenry, 20 into 10 power minus 3 millihenry into C equivalent. So on solving, the value of C equivalent is 1.266 into 10 power minus 12. We know that C equivalent is C1 C2 by C1 plus C2. Its value is 1.266 into 10 power minus 12. Given C1 is 4 picofarad. Substitute the value of 4 picofarad in C1. 4 pico into C2 by 4 pico plus C2 is equal to 1.266 into 10 power minus 12. So 10 power minus 12 can be written as picofarad. So on calculation, the value of C2 is 1.8525 picofarad. So the capacitance value is 1.8 picofarad. Now the feedback factor beta. Feedback fraction beta is the ratio of C2 by C1. C2 is 1.8525 picofarad by C1. C1 is 4 picofarad. It results 0.4631. 0.4631 approximately 0.45 as per the option. So correct answer is 3. The value of capacitance C2 is 1.8 picofarad and feedback fraction beta. So this is feedback fraction beta is 0.45. Next question. For a UPS uninterrupted power supply system, the following specifications are given. UPS rating is 20 kVA, kilovolt ampere, and inverter efficiency at full load is 85%. The type of load is inductive So lagging power factor of 0.8. The battery needs to supply at least, we know the power triangle. From the power triangle, 20 kVA. Okay. The output power is apparent power into power factor. From the power triangle, output power is equal to apparent power into power factor. Here the apparent power is 20 kVA, 20 kVA, and the power factor is 0.8. Now the value of output power is 20 into 0.8, that is 16 kilowatt. No, the maximum real power that uninterrupted power supply can supply to the load is 16 kilowatt. Now, power output from the battery is power output power by inverter efficiency. Output power is 16 kilowatt and the inverter efficiency given is 85%, that is 0.85. The answer is 18.82 kilowatt power. 18.82 kilowatt power. The correct option is 3. Next question. Arrange the following semiconductors in decreasing order of band gap at 0 Kelvin. So decreasing order of band gap at 0 Kelvin. This AIP aluminum phosphide band gap is 2.45, carbon, that is diamond, 5.47 electron volts, cadmium selenide CdSe 1.74 electron volts, gallium nitride GiN 3.4 electron volts, lead selenide PbSe 0.27 electron volts. In the question they have asked decreasing order of band gap. So highest is for carbon, that is B. Highest is for carbon. In the given options, the highest is for carbon and lowest is for PbSe. So PbSe is E. Here it is option B, highest, and for option E, PbSe lead selenide, it is lowest, and the sequence is BdAcE. Correct option is 2. Next question. It is related to modulation or demodulation in list 1 and list 2 represents its corresponding term. So let us see the points here. WDM, wavelength division multiplexing, it is used in fiber optic transmission technique that enables the use of multiple light wavelengths to send data over the same medium. The bandwidth of frequency modulation, it is given by Carson's, it is calculated by Carson's rule. The bandwidth is, the formula for bandwidth using Carson's rule is 2 into delta f plus where fm, where delta f is frequency deviation and fm is the highest modulating frequency. And this photodetectors is an optoelectronic device that converts incident light or electromagnetic radiation into ultraviolet, visible or infrared spectral regions into electrical signals. Photodiodes, PN photodiode, PIN photodiode, Schottky photodiode, avalanche photodiode, phototransistors, photoconductors, photomultiplier tubes. Next, DSP-SC receivers, double sideband suppressed carrier receivers are coherent detection, Costas loop and squaring loop, whereas DSP-SC modulators are balanced modulator and ring modulator. FM, frequency modulation, so it is related to Carson rule. FM is Carson rule. DSB-SC, Costas receiver. PIN, PIN is a photodetector. PIN is a photodetector. optical communication, wavelength division, multiplexing. So correct option is A3, B1, C2, D4. Correct option is 1. Next question. For thin film vacuum, for thin film deposition, for thin film deposition, vacuum coating is used. The need for vacuum coating is, so to avoid contamination, for thin film deposition, vacuum coating is used. Coating unit is preferred because first to avoid contamination from atmospheric gases or particles, and second to increase mean free path of evaporated or sputtered atoms or molecules so that they can travel longer distances without colliding with the gas molecules. So here the need of vacuum is to avoid contamination and to increase the mean free path. Correct option is 1. Next question. Calculate the modulation bandwidth of gallium arsenide based light emitting diode with carrier lifetime of 200 picoseconds. The formula for modulation bandwidth is, for an LED is related to this modulation bandwidth of an LED is related to carrier lifetime, and the formula for modulation bandwidth is 1 by 2 pi tau. So that is 1 by 2 pi tau. Carrier lifetime is 200 pico 10 power minus 12, 200 picosecond. On calculation, its value is 796 into 10 power 6, that is 796 megahertz. Correct option is 2. Next question. The sequence of steps for n channel polysilicon gate is, so first step is grow patterned source drain and gate oxide 500 Armstrong thick, that is initial oxide patterning. Initial oxide pattern. This is the first step. Next is gate formation step. So that is statement A. Gate formation, first step. Second step, that is grow 200 to 500 Armstrong thick gate oxide followed by polysilicon gate deposition and etching to define a gate. And third step is statement C. N channel diffusion is made for source and drain regions keeping gate heavily doped, that is source and drain formation. Source and drain formation. So this is third step. And finally a layer of PSG polysilicon gate is deposited, reflowed, followed by metallization for source, drain and gate. So that is final passivation, and contacts, and forming contacts, metal contacts. This is step 4. So correct option is B, A, C and D. Correct option is 1. Next question. For a solar cell, load current is 100 milliamperes and reverse saturation current is 1 nanoampere. Find the open circuit voltage. So solar cell is a device that converts photons from sunlight or solar light into electricity. And the formula for open circuit voltage for the solar cell is VOC is equal to VT into ln of 1 plus JL by JS, where JL is reverse saturation current density, that is JS, and JL is photo current density. VT is a thermal equivalent voltage. So in the question, so thermal equivalent voltage is 26 millivolts at room temperature, logarithm of natural logarithm of 1 plus load current that is 100 milliampere, 100 milli by 1 nano, that is 10 power minus 9. 26 into 10 power minus 3 ln of 1 plus 10 power 8. So its value is 0.479 volts, approximately 0.48 volt. Correct option is 4. Next question. Calculate the gauge factor of a strain gauge in ascending order of parameters. So let us see the definition of gauge factor. So gauge factor is defined as the ratio of per unit change in resistance to per unit change in length. It is a measure of sensitivity of gauge, also known as gauge sensitivity. So gauge factor is also known as gauge sensitivity. So different types of strain gauges are unbounded metal strain gauge, bounded metal wire strain gauge, bounded metal foil strain gauge, semiconductor strain gauge, and diffuse strain gauge. The formula for strain gauge G is 1 plus 2 nu plus dou rho by rho divided by dou L by L. When strain is neglected, the strain is neglected, then gauge factor G is 1 plus 2 nu. So that is 1 plus 2 lateral strain by longitudinal strain, 1 plus 2 delta D by D by delta L by L. So gauge factor is directly proportional to nu. No. So now nu is delta D by D divided by delta L by L. So for option A, delta D by D is 0.02 by 1.5, delta L by L is 24 millimeter by 1 millimeter. So its value is 0.32. For option B, 0.02 1.5 into 15 by 1, its value is 0.2. For option C, delta D is 0.01 by D, it is 0.5 into 15 by 2, 0.15. For option D, 0.02 divided by 0.5 into 20 by 2, its value is 0.4. In the question, ascending order of strain gauges. So ascending order of strain gauge means ascending order of G. So ascending order of G, indirectly it is ascending order of V. So here highest is for option 4 and lowest is for option highest is for option D and lowest is for option B. And lowest is for option C. Therefore, correct answer is C A, C B A D. So for D it is highest, for C it is lowest. Gauge factor is highest for given option D and lowest is for given option C. Next question. What is the output voltage V0 for the figure shown below? So the given figure is inverting operational amplifier half adder circuit. Output voltage is minus RF by R1 into V1 minus RF by R2 into V2. So therefore output voltage V0 is here feedback resistor RF is 10 kilo ohm. Let us assume this is R1 voltage V1, R2 voltage V2. Output voltage is minus RF by R1 into V1 minus RF by R2 into V2. So RF is 10 kilo ohm by 4 kilo ohm into V1 is 2 minus 10 kilo ohm by 4 kilo ohm into 2 volts. So its value is minus 10 volts. Correct option is 4. Next question. For a transducer, four different statements are given. Identify the correct statements. A transducer, let us see some basic points related to transducer and inverse transducer. A transducer converts non-electrical quantity into electrical quantity. It converts non-electrical quantity into electrical quantity, whereas inverse transducer converts electrical quantity into non-electrical quantity. Input of transducer is non-electrical, output is electrical quantity, whereas input of inverse transducer is electrical quantity and output is non-electrical quantity. And examples of inverse transducer are piezoelectric transducer, current carrying conductor placed in a magnetic field. Many data indicating and recording devices. So recording devices are practically inverse transducers. Oh. Statement A. A transducer converts non-electrical quantity into electrical quantity. Statement A is correct. Statement B. Inverse transducer converts electrical quantity into non-electrical quantity. It is also correct. So data indicating and recording devices are inverse transducers. Statement C is correct. Current carrying coil or rotational displacement in a magnetic field, it is an inverse transducer. So A, B, C are the correct statements for inverse transducer. Correct option is 4. Next question. Which of the following statements are correct for an oscillator? So it is an Bark-Hassan criteria. The total phase shift around the closed loop is 0 degrees or 360 degrees, and the loop gain must be unity. This means feedback signal must be in phase with the input signal to create a positive feedback loop for sustained oscillations. So correct options are the loop gain should be unity, and total phase shift is 0 degrees or 360 degrees or 2 pi radians, where the feedback signal is in phase with the input signal to create a positive feedback. Correct options are A and D. Correct statements are A and D. Correct option is 2. Next question. In 8051 microcontroller, what will be the content of accumulator after the execution of following instruction? So move instruction is given, rotate right is instruction is given, complement and swap. So let us see these instructions in 8051. Swap instruction. So this swap instruction interchanges the highest and high and low nibbles, that is 4 bit groups of the accumulator register. This operation effectively rotates the bits within the accumulator by 4 positions. No flags are affected by this instruction. Next is rotate. RRA instruction rotates the 8 bits within the accumulator, that is bit 0, least significant bit of the accumulator is moved to most significant bit, that is bit 7, and all other bits are shifted by one position to the right. Next, CPL stands for complement. It is an one operand instruction that inverts the value of the specified destination operand. Okay. Initially, accumulator A contains CH hexadecimal. So in binary, it can be written as accumulator A contains C is 1100 CD 1100 and D is 1101. Next instruction is rotate right accumulator. So rotate right accumulator. So it contains After executing this instruction, this LSB bit is moved to highest position 1110 0110, and all bits are shifted by 1 bit right side. Next is complement accumulator. So ones become zeros and zeros become ones. 000 1 1 Next is swap. So after executing this swap instruction, swap accumulator, LSB bit become MSB. This is and MSB nibble become LSB nibble. So that is 1001 000 1. So 1001 is 9, 001 is 1 hexadecimal. The content in the accumulator is 91H. Correct option is 4.